From the deepest oceans to the highest mountains, life on Earth is everywhere. But what if animals could live in the vastness of space without human intervention? What if the universe wasn't just a cold, empty void, but a frontier waiting for its first natural explorers? Today, we're going to dive into this incredible thought experiment and explore the fascinating possibilities of life beyond our planet. We'll look at some of Earth's most resilient creatures and imagine how they might not just survive, but thrive in the harsh conditions of the cosmos. Some of Earth's creatures already push the boundaries of survival. They live in boiling volcanic vents, under miles of crushing ice, and in deserts with no water for years. What would it take for these ultimate survivors to call space their home? Which traits would give them the edge in a world of zero gravity, lethal radiation, and absolute zero temperatures? Let's start with the undisputed champion of survival. A creature so tough, it almost seems like it was designed for space travel. Meet the tardigrade, also affectionately known as the water bear or moss piglet. This microscopic marvel, usually less than a millimeter long, can survive conditions that would instantly kill almost any other known life form. It can withstand radiation doses hundreds of times higher than what's lethal for humans, endure temperatures from just above absolute zero to well over 150 degrees Celsius, and even survive the vacuum of space. In 2007, scientists actually sent tardigrades into low Earth orbit, exposing them directly to the vacuum and solar radiation. When they returned, many were not only alive, but also able to reproduce. They achieved this incredible feat through a process called cryptobiosis, where they enter a state of suspended animation, retracting their limbs and dehydrating themselves into a tiny, indestructible speck called a ton. In T-state, their metabolism drops to less than 0.01% of normal. Imagine these tiny pioneers drifting through the cosmos inside meteoroids, dormant for centuries, until they crash land on a distant, water-bearing moon. They could reanimate and start a new lineage of life, billions of miles from home. Tardigrades might be our best candidates for cosmic life. But what about larger creatures? Something we can actually see without a microscope. Let's turn our attention to an animal that many of us are less fond of, but whose resilience is legendary. Cockroaches are notorious for their ability to survive just about anything we throw at them. They can live for a week without their heads, hold their breath for 40 minutes, and withstand radiation levels that would be fatal to us. In space, their tough, flexible exoskeletons would provide a natural, built-in spacesuit, offering protection from small impacts and the vacuum. Their simple dietary needs mean they could likely find sustenance from organic matter found in cosmic dust or on asteroids. And their rapid reproduction cycle is a huge advantage. A single female can produce hundreds of offspring in her lifetime, ensuring the colony's survival even with high mortality rates. But how would they adapt to zero gravity? Over generations, their bodies would change. Without the pull of gravity, their legs might evolve to become more like creepers, allowing them to cling to surfaces. Their antennae, already incredibly sensitive, would become even more acute, detecting faint chemical trails and vibrations in their new, silent environment. Imagine a colony of futuristic cockroaches living on an asteroid, carving out tunnels and creating a complex society in the rock. They wouldn't just be surviving. They'd be engineering their own little world, a testament to life's stubborn refusal to quit. But space isn't just cold, dark, and airless. It's also constantly bombarded with deadly radiation from stars and cosmic events. How could animals protect themselves from this invisible threat? For that, we look to another creature from Earth's deserts, the scorpion. Scorpions have a secret weapon. Their exoskeletons contain proteins that fluoresce or glow under ultraviolet light. While scientists are still debating the exact purpose of this glow, one leading theory is that it acts as a massive sensor, helping the scorpion detect and avoid harmful UV radiation by scurrying for cover. In the harsh environment of space, where an unprotected organism would be fried by solar flares and cosmic rays, this adaptation could evolve into a powerful, natural shield. Perhaps their shells could develop properties that not only detect but also reflect or absorb harmful radiation, protecting their delicate internal organs. Picture a spacefaring scorpion, its body armored with a shimmering, radiation-proof carapace, crawling over the cratered surface of a moon, its tail poised, not just for defense, but as a multi-purpose tool for anchoring itself in low gravity. Now let's consider a different kind of challenge. The sheer emptiness and distances of space. Life needs a medium to exist in, and for most life on Earth, that medium is water. So how could aquatic life make the jump? Let's look at rotifers. These are another group of microscopic, aquatic animals. Unlike tardigrades, they possess the amazing ability to survive complete dehydration. They can dry out into a tiny, dust-like particle and remain in suspended animation for years, maybe even decades. When they re-encounter water, they spring back to life in a matter of hours. In space, they wouldn't need a planet with oceans. They could travel within micro-droplets of water, trapped inside comets or asteroids. Imagine vast swarms of them, trillions of individuals, drifting through the void inside a cosmic ice cube. They would be completely dormant, little specks of potential life waiting for the right moment. If their icy vessel were to crash on a planet with liquid water, or even just pass through a nebula with the right chemical composition, they could reawaken and instantly populate a new environment. They are nature's own message in a bottle, cast into the cosmic ocean. Survival in space would mean profound evolutionary changes. It would require new bodies, new behaviors, and a complete redefinition of what it means to be alive. The descendants of Earth's cockroaches might develop metallic shells, incorporating minerals from asteroids. Tardigrades could evolve to actively harvest energy from radiation. Scorpions might lose their eyes entirely, navigating by sensing magnetic fields. It's a journey of adaptation on an astronomical scale, a new frontier for life itself. We often think of space exploration as a human endeavor, something driven by our technology and our ambition. We send rovers and telescopes to peer into the unknown, dreaming of one day setting foot on other worlds. But perhaps we're not the only ones with cosmic aspirations. Nature may already have its own pioneers, small, tough, and perfectly equipped for the journey. They may be traveling the starways right now, hitching rides on asteroids and comets. Silent astronauts on a mission billions of years in the making. While we dream of exploring the stars, life itself might already be out there, stubbornly and ingeniously finding a way in the endless, beautiful, and terrifying expanse of the universe. Life finds a way. Thanks for watching. If you enjoyed this journey into the cosmos, don't forget to like, subscribe, and hit that notification bell for more explorations into the wonders of our universe.